Bismillahirrahmanirrahim. Assalamu alaikum warahmatullah wabarakatuh. Dear students, BS Physics, Smester-1, Mechanics-1, course code 1103, lecture number 11, chapter 4, Two-Dimensional Motion. This lecture contains the kinematics in the two-dimensional motion and two-dimensional motion. I am talking to you, Rashmat Ali, Assistant Professor of Physics, Khwaja Preet, Government Postgraduate College, Ream Assam. Dear students, the material of this lecture has been taken from the book as recommended by the University, Physics for the Scientists and Engineers by Survey Javed. The second reference book, Fundamentals of Physics by Gerald Walker. First of all, the main contents of this lecture. Mechanics is a whole paper according to two dimension. We get a small review, position and position vector, displacement, velocity, acceleration, two-dimension motion, and two-dimensional motion with constant acceleration, further two-dimensional motion. First of all, the mechanics review. Review means something we already know, just we are going to review them, to revise them. Mechanics has the two types, two main branches. One is the kinematics and another is dynamics. Kinematics is the motion of particle without reference to force and mass, whereas dynamics is the motion of particle with reference to force and mass. So kinematic of two dimension, how will we study it if force and mass both are not referred? Then motion of a particle in two dimension can be described in terms of displacement, velocity, and acceleration. Next, to describe a motion in two dimension, we must know the position and the position vector, also the velocity and the acceleration. First of all, the position, the location of a particle with respect to some reference axis is called position. Suppose we want a location of a particle, of a body, of a person. We must have some reference axis as seen from the figure. This is XY plane and used as a reference axis. A body is moving along a curved path. 2 points A and B are the two positions of two particles. A is the position of a particle of a body at time ti during its motion, and B is the position of a particle at time tf during its motion. The position plays an important role. The motion of a particle moving along a straight line can be completely described if its position is known as a function of time. Next, position vector. Position vector is the vector that describes the position of a particle with reference to some fixed axis. It is a vector denoted by R, whose tail is at origin and head is at the given point. Here, if we see the figure, point A and B are two positions, and their positions can be described by two vectors Ri, Rf, Ra or Rb at time Ti and Tf. Displacement, the change in position of a body from initial position to final position, is known as displacement. Let a particle moves from position A to position B in a curved path, then the displacement in this interval can be written as delta R, Rf minus Ri. Here no vector sign is put over the vectors because boldface characters are used here. The direction of delta R is from A to B. Note, distance and displacement. Normally, if a path is a straight line, this distance will be equal to the displacement. But if the path is curved, then distance must be larger than the displacement. It is also to note, displacement is same in all dimensions, whether 1 dimension, 2 dimension or 3 dimension. Second one is the velocity. The time rate change of displacement is called velocity. Velocity is a concept that accounts both displacement as well as time. Its formula is delta R over delta T. Its SI unit is meter per second. Average velocity, because this is mechanics review, short definitions are quoted here. The detailed definitions we have studied in one-dimensional motion. Average velocity, the total change in displacement divided by total time taken, is called average velocity. The average velocity of a closed path is 0. Closed path means a circle, rectangle, or any zigzag path. If we start our motion from certain point, after covering some distance and end our motion on the same point, that will be the closed path. Closed path, the average velocity will be 0 because the displacement will be 0. Now the instantaneous velocity. The limit of the average velocity delta R, delta T, as delta T approaches to 0 is called instantaneous velocity. This is mathematical formula. If delta T is so small, the interval is very small, that delta T approaches to 0, then Derivative of displacement with time is velocity. Acceleration. Again, this is a review. The time rate change of velocity is called acceleration. Mathematically, we can write as delta V over delta T. Average acceleration is the total change in instantaneous velocity divided by total time taken. Similarly, instantaneous acceleration, the limiting value of delta T over delta V over delta T as delta T approaches 0, this is called instantaneous value. Instantaneous acceleration, the acceleration is produced either change in displacement or velocity or both. Suppose a body is moving in an XY plane, a curved path, blue colored line at point A. This is the position of a particle at instant Ti. The velocity will be tangent to the point Vi, and at point B, this is second position of a body at time Tf. The velocity will be Vf tangent to the point B. If we take velocity vectors, we can get the change in velocity, the final minus initial. These both vector addition. This is the vector addition of velocity. Velocity vectors can be added in this way. Delta V is the velocity and delta T is the given time interval. So we will find the average acceleration and the instantaneous acceleration. Two-dimensional motion. Motion of a body in a plane is called two-dimensional motion. If a body is moving in a plane, so then this motion will be called two-dimensional motion. For example, a body moves in a circular path, circle, then its motion will be called a two-dimensional motion. Similarly, the projectile motion is also an example of two-dimensional motion. Sometimes it is asked in paper that differentiate between one-dimensional and two-dimensional motion. One-dimensional motion, motion of a body along the straight line is called one-dimensional motion. And two-dimensional motion, motion of a body in a plane is called two-dimensional motion. Two differences are given. Three equations of motion, Vf equal to Vi plus At, this is the first equation. S is equal to Vit plus 1 by 2 At squared, second equation of motion. 2As equal to Vf square minus Vi square is the third equation of motion. Similarly, in two dimension, position vector, velocity vector and acceleration vector have the two components. One of them we call an x component or horizontal component, another as the y component or vertical component. Two-dimensional motion with constant acceleration. This article is considered as a long question. So, the two-dimensional motion can be understood if we take the motion of a body. First, the case is constant acceleration. Means velocity increases or decreases in equal intervals of time, where the time intervals is very small. So consider a body is moving with constant acceleration in magnitude and direction in two dimension. So we write the position of a body as r is equal to xi plus yj. Here x, y, r may change with time as the body moves, while I cap and j cap remain the constant because these are the unit vectors to show the direction of a vector at a particular instant. Velocity is the rate of change of displacement with respect to time. So, taking time derivative of this equation, we have dx over dt I cap plus dy over dt into j cap equal to vxi and vyj. Similarly, the acceleration in two dimension can also be studied here. So, two-dimension motion with constant acceleration. Now we are going to study the equations of kinematics. That is the equation of motion, first equation, second equation of motion. The two components of velocity are, we know, first equation is equal to Vf equal to Vi plus At. So along x-axis, just we put the sign subscription of x, and along y-axis we put the y subscription. So we can write the velocity as the two components, putting the value and managing them. Then we have the first equation of motion as Vf equal to Vi plus At. We can see this from the graph 2. Here, Vi is the initial velocity. At some instant, the velocity has changed to Vf, but this change produces acceleration in certain time. A into t becomes the velocity again. Vi has the two components Vxi, Viy. Similarly, At has the two components Axt and Ayt, and Vy has the two components Vxf or Vyf. These are the two components. If we add them by head-to-tail rule vectorially, then we again get the same result, that is velocity Vf equal to Vi plus At. This is shown in the coordinate axis. Similarly, the x and y components can be written in this form, second equation of motion, x f equal to xi plus y ix vix into t plus 1 by 2 ax into t squared. Similarly, y component vf equal to yi plus viy t into t plus 1 by 2 ayt squared. As we know that the position has also two components, rf vector equal to xf I cap yf j cap, putting the above values and managing for them, rf would be equal to xi plus vit plus 1 by 2 at square. It is shown in the coordinate axis. Again, r is the initial position vector. If a body moves with velocity vi, then vit is the vector, position vector for second vector. Similarly, if a body changes its velocity from vi to vf, then it must have acceleration 1 by 2 at square is also a displacement. We resolve them into their components, then get the resultant component xf xi plus vxit plus 1 by 2 axt square Similarly, the y component, and finally the resultant displacement. Thanks, all of you, for listening with patience. Allah Hafiz. Goodbye.